Chukwudi Joshua, are you there with us?
Yes, I can hear you, Kenneth. I think we'll have to postpone it to the end of the meeting when they've joined. So I think it's the best for the president of SME to do the introduction of XM by himself.
Okay. All right. Since we have that, and as well, I also wish if we can have the video coverage of this session. I'm trying to see if there's a way we can get that in as if there's a way we can get that one possible. And that we can have the audio recording, but then if possible we can have a video recording of it. But then we
Yeah,
keep trying.
yeah. That will be made available to you. I've started the recording right now, so don't worry. You get that. Yeah.
Oh, all right. Thank you very much. So great
Yeah.
about that, sir. So without much further ado, we like to kickstart the program because we have limited time with us and not to waste much of our time. So the stage is yours, Mr. Engineer Taiwo. You can begin with us, sir. Thank you very much.
Yeah, okay. Thank you everyone for having me here. As the moderator have introduced, my name is Blessing Taiwo, and I'm a technical specialist as working at WipWare Technology, working with WipWare. I'm a technical specialist, and I focus on WipFrag software training, application interpretation, and majorly to students and also to engineers for application. So, and today I will be taking the training out to you guys on how to use the WipFrag software, the guide, and how to interpret the results, definitely today. So, then I want to also inform everyone attending this training that after the training, it's expected of everyone interested that a certificate will be made available for you through the SME. I believe it communicated that to you. So, and if you're attending right now, you are satisfied for a certificate after completing a given assignment as a task. So, and okay, yeah. So I have a few slides here. I just want to run through it so that to lay a foundation of what the software is capable of doing and what you as a mining engineer can benefit from it, apart from just having the head knowledge, how you can interpret the results and, bring out the usefulness of what you are analyzing to enhance the operation in any site, be it a quarry, be it an open pit, underground mine. So right from over time, people have keep complaining like it's not possible to do, fragmentation analysis underground. Yeah, so then I was also having a paper focusing on something like that, but it wasn't impossible because it was impossible because there wasn't access to having light underground to do the analysis. But right now, the extension of the technology has actually go wider, and right now you can do fragmentation analysis underground and assess the blasting operation underground. So beginning from my slide, the goal of this training or workshop is to help you, the attendee, understand the importance of blasting assessment, learn about image acquisition techniques, gain hands-on experience with WipFrag software, then master the interpretation of the fragmentation analysis result and how to interpret, how to apply it in real life scenario. Then the question comes up like, why do we need to analyze blasting? Should we just keep doing the blasting operation and moving the material to the downstream? What are those reasons that actually prompts a company or a manager to asking his team to assess their blasting? There are a lot of reasons why we do that. The first reason why mining engineer, after their blasting operation, might be interested in analyzing the material is for reference sake. Probably you are having a lot of pits and you want to keep referencing the blasting operation you have done. as a, maybe you make adjustment to one of the parameters and you want to reference it to the previous blastings, though you can do that by just, visiting the site and looking at what the output of the blasting is. But if you don't have numbers, you know how it is. If you don't have numbers to, qualify and quantify what you have done, then you are not referencing anything. So that's why your supervisor, or when you're doing the research, you copy someone's work, you are requested to have the person's name there that is visible. So with WiFrag giving you quality information about what your blasting looks like, it's just like you having a author name cited in your paper or in your thesis. So you can easily reference and see what is going on in each of the pit flank. Another thing could be you want to assess your blasting based on the fact that you have to comply with some guidelines and rules in the mine. One of the most dangerous operation is just is working in the mine. You don't want to go uh, into an operation whereby you leave home and you can't return in the evening because of an incident. So necessity is placed upon, guiding the rates at which blasting is done, the quantity of explosive being used, so as not to, damage the environment, contributes to, impacts like fly rocks, eating people, destroying properties, ground vibration. So you want to comply with that. Then you just have to adjust your parameters, but still yet you are concerned with profit. If you keep mining and you are not making profits, then definitely you borrow loan to pay your to pay the people working with you in the mine. So you want to comply with some rules and regulation in the environment. It could be earth related, it could be ground control related. Then you need to manage the data that you are getting by doing assessments. So it's also buttressed by quality control. You know, especially if you are working in a metallic mine, for example, or those people that have went for IT and you have some information about, how the metallic ores or the precious mineral like gold and the likes are being mined. And even in your mineral processing course, you have been taught that definitely when we move the material from the mine site, we are not just interested in moving material. We are interested in moving the quality material, the concentrates, the real ore, not the gang. So, and for you to control the waste, controlling dilution in the pit face, you have to monitor the blasting operation so that you know what is coming out of each of the explosion you are making. So then another thing could be that you want to dictate oversize. The word oversize does describe materials that are bigger than what your crusher can handle. Or in another scenario, for the case of those people that may have interest in research work, it could be defined as materials that are bigger than what your excavator or your loading equipment can handle. So, and everything is just about time. When you check the fleet design, is about time, the loading time, the traveling time, the returning time, the tipping time. So when you have oversized material coming out from your blasting, and your loading operator have to spend a lot of time to try to grab the material and drop it in the bucket, or you finally move the material from the mine site and you get to the downstream stage, you are unable to, process the material directly because the crusher dip is lesser than what the oversized material looks like. So definitely you want to spec those material. You want to first avoid not moving them to the crusher. You want to also avoid producing such material in your next blasting. So definitely it's important that you measure your blasting. Also, another thing could be performance guarantee. It could be product and services comparison. Maybe you have 2 or 3 mines or projects, or you have 2 or 3 explosive type, 2 or 3 designs, 2 or 3 maybe detonating code, and you want to compare them. So definitely you have to assess the blasting and see what the output looks like. And in another way, it could be that you want to assess your blasting for crusher compatibility. You don't want to produce materials that won't be able to go through the downstream operation, your secondary mineral processing stage, your primary stage. All those stages is a function of not just cost, is a function of time, is a function of productivity. So you want to assess your blasting to ensure that the material that you as a mining engineer is producing from the pit phase is not only a material that can be loaded from the pit, but it's a material that can be crushed when it gets to the downstream operation. Then it could be for continuous improvement. You know, a case scenario could be that you perform a blasting and you have a lot of over break, and the over break is now affecting your slope stability, whereby probably you are tending towards failure. So you want to assess the next blasting to ensure that you are not releasing excessive energy that will, thanks to, impacting the wall of your mine. So, and to do that, you don't want to reduce the energy below what will be given, what will support your productivity. Then you want to assess and see what we go through your crusher and what we go through and will not impact your stability. So all what the software does for you is to pick the whole of the material, just like your sieve analysis in the lab. You pass the whole material into sieve class. And in this case, the software is passing the whole material through 25 sieve classes. So it's like you're having 25 sieve set upon each other, and the whole of the blasting is passed through it. And like the lab, you have to keep checking. But in this case, you don't need to do any checking. The software do the process using edge detection and do the necessary calculation and give you the particle size distribution based on percentage passing and retain. So I've explained this. Blasting is just the reduction of the rock mass using explosive. And that process of the whole mine is depending on the whole on the output of the blasting. As you can see at the right flank corner of the screen, you can see the design of the blasting is a bit complicated. You have a lot of parameters, and it's worth noting that you just have everything classified under two. You have the controllable parameters and the uncontrollable parameters. And the controllable parameters are those ones you can manage as a blasting engineer. You can adjust your burden, you can adjust your spacing, you can change your drilling machine and the others. But this operation, as you are doing the adjustment, is having effect on the downstream operation. And you want to monitor that with the output of the blasting to ensure that you are improving productivity, you are not impacting the community, and you are also having enough money to pay your workers at the end of the month. So you can see the pit. So this is just the circle of operation in any typical organization. They have a plan, then they execute the plan, they check the plan if it meets what they want, and they make an action. So in the action, it could be as a case study of a mine. Your action could be you have a production target, you want to meet that, or probably you have a blasting cost you want to reduce, or you have an environmental issue you want to minimize the impact from the blasting, or you want to improve your downstream operation. And that is where the software comes in. It helps you to assess what you have designed, to assess what you have optimized, and check if it has reached what you are looking for, and it gives a balance to you. Okay, so there are many ways you can do image analysis of a blasting. You can decide to check using your ice ball. You can go there and look at what is coming out from the blasting, but that is definitely subjective and it's not quantitative. You don't have numbers to work with. You can also decide to load all the materials and take it to the lab, especially let's say you take it to the mineral processing lab. You see how small it is, and you are moving a whole of a blasting into that lab. You are asking them, Sister Kemi and the likes, the lab attendants, to leave the whole of their space. You the material there, and they assign the student to start sieving the whole of a blasting, let's say from 50 holes. You can imagine the energy you're going to use. You can imagine the time. So all those things actually make it not, it make it impossible for you to sieve the whole of the blasting. Then you need a software that can easily do that work for you. Then the software comes in place of photo analysis. All the software is requesting from you is an image. And for you to get that image, there are guidelines you have to follow. And that's why in the beginning, I've mentioned the important, and now I'm proceeding to tell you how to acquire the image. because that is the only input you are giving to the software, and you have to give it the best. So the next slide, I will be explaining how to acquire the image as a student. You want to take you want to collect images for an analysis in a pit, in a mine, or you are working in a quarry and you are to assess the blasting. You don't want to take a garbage a garbage image and give it to the software and think the software is going to just scrutinize everything for you. WipFrag software is just working based on what you give to me is what I'll process and return back to you. So when you garbage in something, it's garbage it out for you. So it's important to focus on how to take the quality image and a good image that gives a good result for you. So, and another thing is that when you are able to handle the image you need and you take the right image, it saves you a lot of time during the processing stage of the software. So also you can take image using drone, and then the image can be captured automatically by our system. We have system apart from the software. And as a student, I will introduce that to you in the next slide. Okay, as I've mentioned, the name of our company is WipWare, and the company have their technology providing solution to both underground and surface mining, providing solution to quarries, to aggregate production, to coal, to forex. The software and the products are being used both on land and in aerospace. We provide solution to agricultural, we provide solution to biosphere, medical, and more. And we have systems that analyze material on conveyor and on trucks in real time. The company is based in North Bay, Ontario, Canada, and it has been in existence since 1986. So it's a technology that have a very long age, and it has been in existence in now with better improvement. So most of the people here in this meeting, probably the software and the technology is older than everyone. So you can see that the technology is not only leveraging on its ability to incorporate new phase of techniques and algorithm, but you also have experience on how it's been done in the traditional ways and how to, balance what is on site now to what has been in existence before. So this is just the history of the company, how it begins, how the whole of the research started from. So the word WipFrag is just the word WIP is from the full meaning, the Waterloo image enhancing process, then the frag for fragmentation. So it was founded. The story is just there for you. If you need that, you can get the slide. So that's just how it moves down to the new technology. As I've mentioned earlier, we have other products, which is the online system. The one I'm going to be giving you training on today is the WipFrag. The technology also extends to the Solo, which is the system that is capable of capturing image on a moving conveyor belt and give you a real-time analysis result. Then the Reflex, which is the system that is capable of capturing image from truck when a truck is dumping the material maybe to the stockpile or to the crusher hopper. It takes time. When the tipping stage, then the material starts coming out. So we have a system that is capable of capturing picture from the truck right from the beginning of when it arrives at the crusher hopper till the truck is done dumping the material. So the camera can take picture per seconds depending on the timing you set it and do the analysis instantly. So then the Solo system captured material on a moving conveyor belt. Then the module is just like a system that you can use to send command based on the material analyzed. So you can set a if statement that when the size is at this stage, close the crusher, set an alarm and the like. So that's what the module stands for. So here is just the only introduction I will be giving you regarding the system, and being a prominent upcoming mining engineer from a university of your interest. So I want you to be up to date to what technology is right now. So that's why I added this slide for you to know that I'm just beyond you going to the mine site, taking picture every time. Things have actually moved forward to you being able to do it automatically. So the yellow dots that you are seeing where a cable excavator is loading is a sign of the drone. You can capture the image of the mock pile using drone and do the analysis on the software directly. And the green dot is just showing the WipFrag. You can go there with your smartphone, take the picture, import it to the software, or take it with the software and do the analysis. Then on to the other side, you can see a truck trying to tip material into a crusher, and that is just a cone crusher trying to reduce the size of the material and pass it through the conveyor belt. The red dot you are seeing there is a position where the one of our system fits in, which is the reflex 6. So as the truck is doing the tipping, the reflex 6 is capable of taking the picture beginning till the end and doing a real-time analysis. So every of the material phase that is coming out of the bucket is being captured, is being analyzed, and you are getting the results in your office without doing any work. You don't need to go there, put scaling object and the likes. That will be done. Also in underground, definitely you have the material coming out maybe from the all pass, or the draw points. So you have your LHD, that is the load all dump, trying to move the material from the all pass or from the all dump place in underground, or maybe from, let's say, the draw points to the all pass. So the reflex system also can capture the material right there and analyze it on the bucket of the LHD. So the green line, the blue dot you are seeing on is just a representative of our system fitting on a conveyor belt. And as the material is moving on the conveyor belt, each phase of the material coming in contact with a designated portion of the conveyor belt where the camera is mounted can be analyzed in real time. And this is just the picture of how the system looks like. And if there's any question on that, I can open an interface of that for you to see how the material is captured from a conveyor belt and be analyzed, and you can get familiar to how that works. And one of the advantage of this system is that it can be integrated into a company dispatch system. To those people that work in Dangote, they have a dispatch system where they monitor how the material is being moved. So the system can be integrated into the dispatch system. So today's training will be spanning from image acquisition to full analysis of image on WipFrag software, then how to use the editing tool, the particle size distribution curve. So this is the basic stages that is involved when you want to analyze material using image analysis technology. So, and that is applicable in WipFrag too. So maybe you are doing your thesis right now and you need like a flow sheet. So this is the standard general flow sheet of how everything works. Image acquisition, you get the image, you do the scaling, you do edge detection, you edit, then you generate the particle size distribution curve. And I will take you through this process in a jiffy after the presentation. So this is how it works. You can get your picture using phone. You can get the picture using a digital camera. You can get the picture using drone. You fly the drone on it. So I will show you how to analyze drone image when we get there. So you can also capture the image underground. So no more limitation of we can't do underground. Now there is provision. So in this presentation, I will also show you how to set up lights. Maybe you are employed in an underground mine. You are in charge of the blasting or monitoring or assessment. I will give you a preview, detailed information on how to set lightning underground to get a good quality image for your analysis. So today I'm starting with the image acquisition for a detailed information. So as I've said, the image could be from the surface, from a surface mine, and it could be from underground. So if you are capturing image on the surface, you can either capture the image as terrestrial images, which is such image you captured using a digital camera or your cell phone. Then you can also capture an aerial image, which is image you captured using drone to generate auto-mosaic image. So here we go. So if it is surface, as I've mentioned, you get terrestrial image or area. If it is terrestrial, you capture using a digital camera or you capture using a cell phone camera. So this is just an example of someone trying to capture the image using cell phone, okay? So this is when you are capturing, when it is terrestrial image that you want to use for your analysis. So you have two options. The first option is you are capturing the picture using just your mobile phone, the camera on your mobile phone. and or maybe you are capturing the picture using a digital camera. If the two options that I've mentioned is the case, then you need a scaling object. If you are capturing the picture with your mobile phone and you don't have the software on your mobile phone, you need a scaling object. And I will explain about the scaling objects, how to select the best scaling object, how to position it in the next slide. So then so this is an example of an image capture with a scaling object. You can see a scaling object like a flank is a reference. So place at the bottom and place at the tip in a case study where you have a slope. So I will explain why you need dual scale objects in some scenario very soon. So when selecting a scaling object, you want to ensure that you are using a suitable scale size. Then you avoid using balls. So in the old time of doing image analysis, people use ball. You just place ball on the mock pile. There are different effects that has on the analysis, and one of it is that the balls are definitely you inflate them with air, and anything can happen to that ball when you try to throw it on top of the mock pile. And anything that have to do with error, it can be systematic. So a kind of systematic error can fall in place when you have the ball expanding or contracting. So if you want to select a scaling object, I recommend you select something that you can see. You can easily identify edge to edge of the scaling object. Okay. Yeah, then the second option is using auto scaling. So you want to ask, what does it mean to use an auto scaling with the WipFrag? You use auto scaling feature easily when you are taking the picture of your mock pile with a mobile phone that have the software installed on it. So I believe everyone right now have the software installed on their mobile phone. If you open the software right now on your mobile phone, you will find an option on the software. On the plus icon, you will see camera. When you click that camera, you can easily take the picture of your mock pile, that is the blasted material, using the software interface directly. And in such scenario, the software have capacity to do auto scaling instantly without you putting scaling object on the material. And there is a short video right now we're playing that explains to you how to use the auto scaling feature when you have the software on your mobile phone. So you don't need to go on top of the mock pile every time, put a scaling object. Everything is a matter of time. You don't want to spend the whole of the time going on top of a mock pile. You don't want to endanger yourself in a kind of mine where you don't even have a good safety boot and you are just walking on maybe just your fancy boots, and you don't want to keep climbing on a mock pile that can damage or affect your foot. So you can just download the software on your mobile phone and use the auto scaling feature. So this is the video showing how to use the auto scaling feature. So, and as you can see, when you open the camera on your mobile phone, when you open the camera on your mobile phone through the software, as I've said, there is a plus icon. I will show you where it is when we open the software. Then you see the camera option. When you open the camera option, the first thing you need to do is to let the software identify where there is ground. So you just point your camera down and this green frame will pop up. So the next step you need to do is to align the base of this green frame to the base of the mock pile you want to capture. So this is just to allow the software to, detect the slope of the material. And with the slope of the material, then the ground being identified, the software automatically calculates the scale and assigns scale to the material you just captured. So this is just check. So you can see here in the picture, you can see a red line at the top and a red line at the bottom. So this is an auto scale captured image. So with this, you see there is no any scaling object on it. You don't need to put elements, you don't need to put anything. So you can do the analysis as quick as possible. So we want the analysis to be on the go. So you are done with your blasting, you go to the pit, you just capture the mock pile and you go ahead with your analysis. In some scenario, maybe the person in charge of the scaling object has forgotten the scaling object at home and you won't be able to access the material. We don't want such delay in your process, and that is why this has been incorporated and is very easy to use. So what are those things that you should avoid when you are capturing image for image analysis? The first thing is that you don't want to get too close or walk on the mock pile when you are capturing the image. Then another thing is that you don't want to use the camera flashlight, because that will definitely reflect an image. It will reflect a shadow on the material, and that will affect the time being spent in editing or analyzing your material. Then another thing is that you want to avoid any kind of accidental sampling or other systematical method. So when you are using accidental sampling, you tend to give attention to some portion of the material, and you avoid you don't focus on other side. So that can definitely create a kind of bias. So you have a lot of things. You want to ensure that you don't get poor quality image. Is garbage in, garbage out. So when you get a poor quality image, then the software, you want the software to do what you can't even do. So whenever you capture the image and you yourself, you can see the fragments, you can see the materials. Definitely the software too cannot see it. So you want to ensure you get a good image. Then if you want to capture image for analysis, it's recommended that you capture the image early in the morning, something like early in the morning and when the sun is not yet out, or late in the afternoon, because when you have the sun out, then it's going to cast shadow on the mock pile, and that will definitely affect the image. Also, you don't want to waste the image you are capturing. Some people may want to capture the mock pile and they move far away. They capture more of sky, more of ground, and the mock pile is now very small in the image you are capturing. You don't want to do that. So you want to move closer. Then one of the rule of thumb is that you don't allow any single particles to occupy more than 20% of the whole image area. Then you want to stay away from wide angle lengths, because they have effect of edge distortion. So you want to avoid them when capturing your image and when selecting uh, um, camera for your image collection. So this is for the drone. For you to capture image using the drone, the first thing is that you need a drone. Then the second thing is that you need to set a flight. You need to design a flight pattern, and you can do that with Pix4D or Drone Deploy. So these are just third-party websites or software where you can just check them online. You register with them, and then you can set the flight paths. So what those Drone Deploy, for example, does for you is that it allow you to set the characteristics of those pictures you want the drone to capture, and it gives a guideline to the direction where you want the drone to fly over. So in this case, you don't need to have the drone, you don't need to be in control of the drone, flying the drone yourself. So, like for example, the Drone Deploy, we generate the flight path. As you can see this picture, you can see those paths being generated. So on the Drone Deploy, you design the flight path yourself. Then when you hit the drone, when you launch the drone go exactly as you have designed it. So I think I have a video there that will definitely explain to you more what I'm saying. Then what are those things that you need to put in mind when you are designing the flight path for the drone? The first thing is that you need to know the model of the drone you are using, so that you have understanding of the battery life. You don't want to launch your drone on top of a mock pile with a battery life that will not be able to complete the flight. The drone can just fall, and something can happen and you lose the drone. Then when you are setting the drone camera, this drone camera must be set at 90-degree perpendicular to the ground, the bed view. Then you want to set the image overlapping to 80%. Then you want to set the flight mission altitude to like 30 to 60 meter high. So the height of the flight of the drone must be up to like 30 to 60 to avoid any form of distortion. So you define the geofence that encompass the black material. So what that is explaining is that when you are designing the flight pattern, as you can see this yellow grid line, is when you are telling the drone where to fly through. So you don't want to design the grid line. Maybe you are including ground where the material. So the flight geofence must just cover the material you are about to analyze only. Then you want to take note of any special warning that may appear when you are trying to design that. So then if the flight conditions are acceptable and clear to start, connect your iOS device to the drone remote control and launch the mission. So this is more of practical, and I don't even know, maybe FUTA has a drone. So I will have like to talk to the HOD to give you guys an opportunity to text the drone, but I'm not sure. Do you guys have a drone? XME president.
No,
Do you know if FUTA,
no,
if mining has a drone?
no, that information is not certain. We do not know if we have a drone in the
Uh,
department.
okay, what I will do for you, I will just remind me. I will contact Professor Afeni and HOD if you know that's the survey aspect. So Professor Afeni will definitely know if we have a drone in the survey lab. So if there is a drone, I can take you guys through how to design the flight path. Though I have a video that will show you that, but it's more practical when you take the drone out and you design, then I can tell you step by step how to operate the DG High Go app and how to incorporate the drone deploy. So that is just that. It's an option anyway. So just remind me, I can help you ask the question and discuss with the HOD about that. Okay, so when you are on the drone deploy, this is just the interface. For example, you can see the green grid line. So that is if you are using the drone in a location, the drone will tell you and bring out the interface of that area like this. So it's left for you to adjust this green frame to cover those area where the blast material is. So you just keep clicking the dot, the white dot, and you adjust it to capture the area where you have the blast material. So this is just a video. So this is how to set the flight path. You can see the grid line. So the first thing is that you adjust the height that you want the drone to fly to 30 meters. That is what I just did. So you click the enhance 3D, you turn it off. Then you click the automatic setting. You set the overlapping to 80%, as I've explained in the slide. Then the side overlapping to will be 80%. So you have the camera to be 90 degree, you can see. Then you turn off anything 3D to avoid any 3D images. So then when you are done with that process, then you are ready to launch the drone. So I will send you that slide. You can watch the video from beginning to the end, but that is just what I want to explain. Okay, let me just play it further to see how to adjust the grid. So the drone deploy website or the app will show you this grid line of where you are standing. If you are in the mine, you will see the mine live like this. Then you can adjust the grid to fit into that place you want the drone to fly all over. So the implication is that the drone, when you launch the drone using the drone deploy, the drone will wholly fly around where you see these green dots and be taking picture. So if you look at this place where my cursor is, the drone, based on the flight design that you have done, the drone will tell you how many pictures it's going to take to cover that area. So so you can see 566 images will be captured based on this design. So I just want to adjust it. So all you just need to do is to adjust. You click here, you can adjust that grid line to cover the area you want the drone to capture images from when you launch it. So you can keep adjusting that. So you can adjust that to whatsoever thing you want, and that's how it works in that area. So if FUTA has a drone, definitely I'll be interested in taking you guys through how to do that. But I have a video that will send to you also that can teach you A to Z how to do that. And that is just for image acquisition with drone. So these are just example of pictures, and those ones that are good and those ones that are bad. So you can see this image. This one is a good picture. You can see we have dual scaling object on it, and it's recommended that you use dual scaling object when you have the pit floor to be slopey. So taking, for example, if you are closer to something, to an object, it becomes bigger. If you move far away from the object, it becomes smaller. So the software is also incorporating that effect to ensure that you are not error is not setting in because of those materials that are further. So with the dual scaling object, it will help you to account for that. And that is what the auto scaling tool will do. So in this case, when maybe you want to go and you want to take sample in a mine, maybe you are employed there and the pit floor or the muck pile is sloping, just use two scaling material, use the auto scaling feature either. So you just put one at the base and one at the top. Then see the other image is blur. This is taken from a tunnel. You can see, you can even identify the material at the top side, at the roof portion of the tunnel. So, and because you can't see it, the software too can't see it. Instead of the person taking this image to move closer, you see the ground space. What is the ground doing in the picture? Are you analyzing the ground also? No. So you can move closer and take more particles, capture more particles in this picture. So this is another one. You can see this is a very good one. This is also a way of using the scaling object. You have the bottom part and the upper part, and it captures more of the material. See the second image. This is not the material this person wanted to analyze here. This is the material top here. What is this ground doing in the image? More of the ground is captured, more of the material is not captured. It's just like taking an exam and a student is done writing the exam and it not put his matric number, it not put his name. Nothing to identify the owner of the scripts, and they mark the script and the guy maybe is called above pass mark, but nothing to reference him. And it's unfortunate that the course could be maybe general course like GNS. The script will be lost. So the material too is lost in this image. See the material up here. How can you see the material that is not, that you can't see over there? So this also other images that is showing good and bad. Using ball, the ball can be deflated and it will affect the shape. Dual scale object, very good kind of image. This is taken late afternoon. You can see there is no shadow. You can see in this case there is shadow. The shadow of the image is affecting, is blocking those material down there. See this very good image, no shadow. See the other one. This is taken maybe in the noon time or in afternoon, early afternoon. Then the sun is reflecting the material and you can see shadow. And if there is shadow there, the software will definitely not be able to do a good job in saving you time. So you have to spend a lot of time in doing the editing, of which we don't want you to do that. We want the software to do the work for you. So this is setting up underground. You want to capture image underground. You need two sets of lights, one at the left, one at the right, both facing at 45 degrees at each other. So you can see, then you capturing the image will be at the center of the two lights and you move closer. You can see the geometry here. So this is how to set up lights underground. You see, the light here is just like, here the person wants to capture the image, only one, maybe the headlamp is just pointing towards one direction. This place is brighter, this place is, there is shadow. So the software will not be able to do a good job here. You have to spend a lot of time. Then you do the work for the software, then the software gives you the final result. But we want the software to do the work of detecting this image for you. So that's why you need a good image. So this is also a geometry of how to set the light underground. The point here, 15 feet, at least 15 feet away from the material, 15 feet away from the material, at 45, 45, 30 feet, the camera position at the center. So this is just this is a video trying to show you how to set up light underground. So this is the mock pile we want to analyze in this case. Light 1, light 2. You turn on the lights. That is my colleague, my team. You turn on the lights. You can see the effects when when my colleague turn on the first light, you can see, then when the second light is turned on, everything comes out and it's very clear. So my colleague is setting the camera at the center, trying to capture the material for analysis right there. So you may need a tripod stand if you want. You can also hold the phone yourself. So this is just showing you how it's being done underground. So this is not cat at Sudbury. This is an underground mine. So I believe you have a clear understanding of the effect of the light underground and how the geometry we have come up with is able to help you very well. So that is that. So we have two techniques of detecting material edge. We have the deep learning, we have the classic edge detection. So the deep learning uses AI to detect the edges of each of the material, and the classic detection use, manual adjustments automatically. So we recommend you using more of deep learning so that the material can be edge detected instantly by the software. So there are two things you want to look forward to when you are selecting your edge detection on the software. The first thing is the fusion effect and the fusion effect. You have fusion effect when the software identify fission effect when the software identify two materials at one. So you have two fragments and the software is identified as one. So then definitely that is called fusion. Then you have fission when the software is trying to identify, break a single material into multiple fragments. So in such case, that is called false positive. So there are tools you use to break it up, but when you are using the deep learning, you have less of that. When you use the classic edge detection, you have more of that. So the deep learning saves you a lot of time and give you a very good result. I just want to show you a comparison between them in this video. So that's just a comparison between them. So is the development that we have right now, yeah, on the software, part of the new development. So that's just a comparison between them. That's what I just tried to show there in the slide. So now to sampling techniques. So how do you developing a sampling strategy? How do you make decision about the number of images you need to collect, where you need to collect the images from? There are a few questions that will help you in this as a professional image analyst. So the first question is that what percentage of the material do you need to be statistically valid? What percentage of that material will you capture in that picture that will tell you that indeed you have covered the whole of the pit face? You just move to the pit face and you cover one section where there is excavator and you leave other section. Do you think that is valid for you statistically? If it is, then you go with it. Then another thing is that what percentage of the material does each image sample contains? So if you want to ask me the question, how many images should I take from a blasting? I will just ask you, how many images do you think you can take to cover the whole of the blast face? If it is 3, if it is 4, then you go with that. Then you want to ask, how will I combine all those images together to represent a single blast? Don't worry. The software have feature called the merging feature. So that merging feature helps you to merge all those images together and represent it as a single blast that it takes. So another question you want to ask yourself is that are material characteristics expected to change throughout the sample? So probably you can have some of the side of the pit having fine material, some of the side of the pit having big boulders. So when you have more fine materials, you want to move closer to the blasting. When you have big boulders, you want to move far a bit away so that you can capture more material. Big boulders will be very closer and occupy a lot of space. And remember, the rule of thumb is that no single particles in the image you are capturing should occupy more than 20% of the whole image area. Then another thing is how important are the decisions you want to make based on the results you are getting. So sometimes if your focus is using the result in your downstream operation, then you know that you need a lot of images to represent the material, and so that you can get the full definition of what the material looks like when you are passing it through your crusher. So in case also when you want to use the result of the image analysis, maybe in separation techniques where you are more interested in a particular size class that will enhance the liberation of, the high concentrate materials, then you want to get more of the fines. You want to move closer and capture more sections, more pictures from the section where you have fines to ensure you are not losing more of the fragments, high grade material to the fine fragment. Then there are different type of sampling strategy techniques. We have the systematic sampling. This is when you collect a specific number of sample based on time. So maybe during you want to cover it during the loading operation, maybe every 10 minutes of the loading operation, you are taking one picture. So depending on that, then we have the probability techniques, we have the cluster and the quarter sampling. So that is that about sampling. I will send you the material, then you also get the video to read about that. So now I will be going to the live demonstration of the software, and I'll be showing you how to analyze image samples, the image from terrestrial using the software, the image from drone, interpreting the results. We'll come back to that on this slide. So let's go to the live demonstration. Then you can just start dropping your question on the chat box for the moderator. So right now I will stop sharing my screen in this section. Then I will be sharing my other screen about the software. So yeah, all right. Can everyone see my screen? Can you see the interface of my software?
Yes, sir.
Oh, okay, good, thank you.
Yes.
So I would first like to introduce you to some of the features on the software. The first thing is that when you open the software, you see the images that you have already inputted in the software display. So all these images that you are seeing on the screen are the images I've already inputted into the software. So the green mark that you can see on the images is showing those analyses that have been completed. So the red dot is showing those analyses that have not been completed. So the number of red dots that you have is just showing the number of those section of the analysis that you have not completed. So like this now is this image, for example, is having 2 deep red. So I'm having two more analysis to 2 more stage to complete this analysis. This I'm having 2 more stage. This I'm having 1 more stage to complete the analysis. So those ones with green are those ones that you have completed the analysis, and the result is ready. Then next on the screen is the plus button. So this is where you add new image to the software. And as I've mentioned, this is the Windows version of the software. On the mobile version of the software, you have 5 options here. Then the 5th option that you'll be having that is not on the Windows version is the camera. So there is a camera option here where you can click the camera and it will show you that interface where you can capture the image yourself using the auto scaling feature. So, and this option here is where you can add image to the software from your laptop or from your local disk. So when you click this, it takes you to your computer and asks you to select where the image is. When you get the image, all you need to do is to click the image and you open it. I just want to click an image now and add it. So I'm clicking, we are using Blast 4 today for this tutorial. So I click the Blast 4 and I open it. So the software will add the image to his window and you can now start the analysis. So let's still leave that for now, but have it in mind that now we have our sample for today added to the software, which is the Blast 4. So I still want to show you more. So the second option is new UAV analysis. This is when you want to add images that you captured using drone to the software. The same way you click that, then you have 2 options. Maybe you have images that you have already stitched together, auto mosaic image. You can add that by clicking open existing. So when you click open existing, it asks you to select the auto mosaic image and add it to the software. So I will show you how an auto mosaic image looks like. Now, here, let me show you. This is an auto mosaic image. I just add an auto mosaic image. So it will take a few minutes for it to convert to his own format. I just want to show you how an auto mosaic image looks like. In case you have such an image, you can add it as a UAV image directly. So as you wait for that to be analyzed, the other option that you are seeing here, like a round ball, is the GIS option. So the GI option allow you to view the analysis on site directly. And the only time that you can have access to use that option is when you have images that you captured with the GPS information. So all the images that you capture with drone, we have the GIS, we have the GPS, that is the longitude, the latitude, and the altitude of the image. So this is an example of an auto mosaic image that you captured from the drone that covers the whole of the pit. You can see this is a blasting and this is the auto mosaic image. This is captured by a drone. The images are already stitched together. So that is that. In this case, I just show you that as an auto mosaic image. So, and the other option you have is that when you capture the images from a drone and you have multiple images, you want the software to stitch it together and give you a plain image, an auto mosaic image like the one I just displayed. So you can just click here and it asks you to select the picture. We are not the one doing the stitching. We do the stitching using a third party website, which is an open source. So all you need to do is to select the images. This is a drone image, and this, all you just need to do is to select those drone image. You can select all, but when you are doing the selection of all, you want to ensure that you don't add auto mosaic image that doesn't have a geotheft properties like this. This doesn't have a geotheft property, and you don't want to include them in the analysis because it's going to crash the whole of the image because this doesn't have a geotheft. So the auto mosaic stitching images that you want to add when you are using this option must be a image that have a geotheft property. That is, it has the longitude, the latitude, the altitude, and also other geotheft properties. Okay, that's how to use that. In that case, I can do an example when I get to place of when I'm done with ordinary image. Then the other option you have there right now that every one of you can access is the demo version, demo images. You download this software, you have access to play around and learn about the software using these demo images. When you click any of them, you can analyze them for free without being a subscriber or having image credits. Okay, when you click them, you can use them. Then you have the auto mosaic analysis image as a sample too. So the last option there is creating a project. Maybe, for example, you are working in a mine and you want to create a project file for all the images that is coming out from a particular blasting. So you can create that file by, you can just name it maybe pit1, pit1, pit2A1, for example. So you can start your analysis. You can put all the images from that analysis. For example, you drag them from here. When you are done, you click, you drop it into the file. You drag them from here, you drop it into the file. So the analysis will be held under this pit 2A. So all the images from that pit is in here. Then another advantage of this is that when you click this file, you can easily see the combination of all the images that you have, all the blast images that you have analyzed from that single pit. So, like for example, I only had 2 images to that file, and this is the two match and the 2 images have been meshed together as one, as summary. So then you can also see the improvements that you are having done in your blasting. So this is the first image, the second image. You can see how the improvement, how you are improving in the particle size distribution of your material. So that is that about creating a file and merging. So I've explained the GIS. Let me just open it. So the GIS connects you back to where that image is captured from. And you can see these are the images, the auto mosaic images that I've captured from a particular mine. And I just want to show you how it looks like. So here, let me just click this and show you. Oh, I've deleted that. I think I've deleted that too. I've deleted most of my auto mosaic images and I don't have them here. So when we do an example, when I use this as an example, then we can see that on the GIX, but I've deleted all those ones that are there in my interface. So we'll use this as an example when we get there. All right, that is that for the GIX. Then all our other systems that I've explained, I explained about the solo system, the reflex system, all are being managed in the software. So I just want to show you a demo of our reflex system, which is the system that is capable of capturing images from truck that is dumping material or moving material. So when the truck is moving the material from the mine site or from the stockpile to the crusher, the system has the ability to capture the image and analyze it in real time. I just want to show you the interface of how it's the interface and how it looks like. And you have access to this on the free software too, on the demo. So the demo version will still show you this too. So this is it. When I click that, oh, I think my colleague is on that. Okay, my colleague is on that, so I want to switch that. I want to switch to another. I want to just give me time. I want to switch to another one. Okay. I'm coming. I want to switch to. I want to ensure that you see the online system. So, sorry, the system, the on conveyor belt, not online. So I want to ensure you see the interface of the system. So I'm trying to add. Okay, I'm coming. Okay, here we go. Okay, here, yeah, okay. I just want to show you the interface of one of the system. So this is the interface of the system. One of our system, the reflex 6 system. It's an hardware, so it has a camera. You mount it as the truck is dumping the material. You can see, for example, the truck you are seeing is trying to dump this material, maybe like dolomite from the pit. So it's dumping it. So the camera capture the picture and do the analysis in real time. So this is the real time. This is the real time information from the analysis being carried out as this truck is dumping this material. This is the particle size distribution curve. So you can see a lot of information here about the D80, the D50, all those particle size distribution information. You can see them right here. So that is that for the online system, for our hardware systems. So these are information you can extract the information based on date. Maybe you are interested in seeing all the material that a particular truck has dumped for the whole day, 24 hours or 12 hours. So you can extract that directly here as PDF. You can extract it in any format you want, and you can see in real time. You can see the time. This is 9 o'clock, 12, 10. So in real time. Then another thing that you can do is Another thing you can do here is that when you have a truck dumping a material from a particular specified hour, let's say from 12 to 3 o'clock in the maybe AM, when you are not in the mine site, you can see what has happened within that time frame. All you just need to do is to highlight the time frame and you see everything. The volume of the material that has been dumped, you can see it. The systems have ability to calculate the volume for you within the time phrase. The D50, the D80, you can add the uniformity index. You can add any information here. Real lifetime analysis. So this is in our lab here, and we are giving that as a demo. Okay, so that's that about our system. Now back to this. The last option here that will be showing as an introduction is the profile. So in the profile, you have your name, you have the number of credits that you have. This is the image credit that I have right now, of which today I'll be giving out some to you. Then this is the subscription information. Then if you have the software and you want to purchase an image credit, you can do that on your mobile phone right there, anywhere you are. So all you need to do, the image credit is what allows you to do analysis on your own analysis on the software. You can add your own image and do analysis, or you can use it for your project. So you need one image credit to analyze one image. So you can buy directly by clicking shop now. So when you click shop now, that interface is not. Can you see the output of the shop now? I don't think so. I don't think you can see that. I just need to show that to you.
No.
Okay, I'm going to show that because of anyone that want to purchase online. So this, when you click that shop now, this will show the image credit is $12 US dollar per credit. You can buy, you can proceed to buy. When you proceed to buy, it asks you about your username and your password. I mean, your WipWare username, the one you created when you were trying to open the app, the WipFrag app. So you log in and it proceeds to check out. You can check out. Then if you want to buy annual subscription, you can buy annual subscription, which is at this rate. You buy now. Then if you are you are working for a company and the company need a quote for a purchase order, then you can just mail us. You can always find, you can access the mail to us, then you can get a quote for that for sure. then you can mail us here. You contact us that you need a quote for WipFrag subscription or for image credit. When you want to purchase image credit, we only send quote for image credits greater than more than 100. So if you just want to buy 2, 3, you can shop online directly using your credit card. Then we have resources library. You have access to tutorial videos and documents. So these are documents, the sampling guides, all of the explanation I've been given on the sampling. Get it here, the manual, then the terms here. So then, and then you can toggle on the settings. You can change the language. If you like to see it in French, then you can change the interface to light or dark. Okay, and just change that to dark. You see dark. Then you can change it to light. That is light. So now I want to perform the tutorial analysis. So as I've said the other time, we'll be using Blast 4. I added the image the other time by following this procedure, which I've explained to you. So when you add the image, it opens up to you. And for example, this is the image we'll be using today. And I just want to let you know that in this image, we'll be using dual scale because of the slope. There's a slight slope in the pit floor. So we want to analyze the material in this phase today and know the size of the biggest material, which is the boulder, which is this, and know the size that supports 50%, 80% passing of this material through a sieve or a crusher. So when you enter your image, the first thing, you have 4 stages to complete your analysis. The first thing is setting the scale. So when you are using auto scale feature, you don't need to set the scale. You'll be using automatically generated scale by the software by itself. So, but when you are using scaling objects like what I'm having here, all you need to do is to click this. This is the first step. The first thing to do here is to tell the software if you are using dual scale or a single scale. And in this scenario, we are using dual scale. Click dual. Then turn on ignore. So the impact of the ignore is that I'm telling the software that I have an object in this image that is not rock. As you can see, our scaling object is not rock. So when you are setting up your scale, the software will identify the scaling object as an object that is not part of the rock material you are analyzing. So that's when you put on the ignore. Then the next thing you want to do is that you want to tell the software the size of your scaling object. So you must know the size of this scaling object you are using. And in this case, we are using it is just 1 meter length. So 1 meter, the upper scale, 1 meter, the lower scale. So when you are setting scale for dual scale, when you are putting the dual scale objects, you want to ensure that they are parallel to each other. You put one at the top, you put one at the base. So parallel to each other is not you put one perpendicular, then the software will tell you an error. So I just want to do that analysis for you now and let that experiment now, and you see the software will tell you that the scale object is having issue. So this is the first scale. You identify what you need to do. Oh, invalid scale, because I don't identify the scale to be parallel to each other, and I don't tell the software the second scale. So here I want to do it again. Here all we want to do here is that we want to identify the edge of that scaling object edge to edge. So this is edge to edge for this scale 1. So then the second scale, edge to edge. So you want to ensure that you use a kind of scaling object that you can see. It's not a very tiny ball that you can't see edge to edge, that you have to do approximation of where the actual diameter is. And that's why selecting scaling object is very important. So doing that, the software has accepted the scale. The next thing we want to do now is generating the edge detection. So we want the software to generate the edge of each of the fragments that is here. And you can do that in 2 ways, the classic and the deep learning techniques. So here we'll be using the classic first. So this is the classic edge detection, what we are using before. So you can see this is where you can understand the concept of fusion and fission. Here we want to identify this boulder, this fragment, as a case study now in this analysis. Now look at what the classic edge detection is showing. It's showing that this material has been fissioned, it has been broken, that it has been disintegrated, and that's not the actual size. So you have to do a lot of editing using the editing tool, trying to trace it, correct for it. Then you can also adjust the slider. When you have more of quartz material, you move the slider backward a bit to this particular portion. Let's see. You can see we are trying to get it, but it's not perfect. So you have to keep adjusting if you are using the classic. But right now we are saving time. You don't need to keep adjusting. Use the deep learning. Click the deep learning, and in the deep learning you have an option for the terrestrial, for the default. So, and in this case we'll just be using the default, which is the up to date. So this deep learning is a continuous training process for the software. So the software keep training using any image users are using. So if you analyze with the deep learning, the software will ask you if you are if the software have done well or not. Then if it has done well, the software learn more on that. You know, as artificial intelligence, you learn with experience. So the software too is learning with experience. So here you click generate. So then the software will just, right now, is just taking 4 seconds. So now let's see the performance of our deep learning. Now we have applied deep learning. See what we get here. Here is the deep learning. You can see we have a very good error detection. We only need a little editing. You can see this material, see this, just focus on it and see. So the first thing you want to do to check the performance of your edge detection is you right click your mouse. When you right click it, you can move it upward. The heat map is generated automatically for you. So you can use the heat map to identify how your edge detection is performing. You see the particles, look at what they have been identified to be. Is it the actual one? Excuse me. If not, then you can proceed to editing. The second button that is available here that you can use to not only assess the performance of your edge detection, but can also use to assess your blasting, is called the edit assist tool, and is right here at the left corner where my cursor is. So when you click this on, how this work is that it identify the material in that analysis based on number. So here I put that edit, I program that edit assist tool to be 15, and the edit assist tool will communicate with the software and identify the 15 biggest fragments in the blasting. So the 15 biggest fragments in the blasting has been identified as this. Now you want to check if they are false positive or not. Now let's start. Is this the actual size of this material? No. This is a false positive identification. Then you click on your tool. This is your editing tool. This is false positive here. This is false positive here. This is false positive here and here. So we want to edit that. You can turn off that. Then check what is going on here. Zoom in. This is the false positive identification. You use the first two here is just like pencil. It's called a free draw. So you use the free draw to join those edges that are not connected and see if they are connected using your heat map. So right click, you can see the heat map again. You can right click once and see the heat map of a single fragment. So that has been settled. This is a false positive here. This is a false positive here. And this is a false positive here. Then zoom in. We have a false positive here too. Okay, no false positive, no false positive, no false positive. We have a false positive here. So then a false positive here. Take in mind also that the quality of this image is very poor. You can see it's not a very good picture. The resolution is not good, but still yet the software still do a good job by identifying to us the fragment. So you can do the editing, then you turn on the edit assist tool again. This is false positive, you check. So you only need to do the editing within a few time before you are done. You just want to ensure that you are not representing the false positive material. So you want to edit anything that is showing false positive. Join those things together and have the perfect one. So when you are doing the editing, you update this and it counts the border for you. So then the second thing that you can do is that you can use the tool to identify, to spec the oversize. So when you are done with your blasting, you want to spec the oversize. And in this case, you can define your oversize based on the crusher size or based on the loader bucket. Now, let's say, for example, I'm working in a quarry and the size of the bucket, the excavator bucket they are using is 500 millimeter. So I want to identify in this blasting which of the material that will not, which of those material in this blast with that my loader will not be able to pick. Or maybe if it is based on your crusher, if your crusher is, let's say your crusher inlet, the gap of your crusher is 500, and you want to identify those material that are oversized, you can use the edit assist tool directly. All you just need to do is to click it one, then the second time, then you long press it and set it to what number you want. So in this case, I want to ensure to put, a factor of safety 450 millimeter. Material that is 450 millimeter are those material in this case study that I will not be able to load, and it's an oversize for me because my crusher will not be able to crush it. So I want to identify them here in this blasting. So the software update that and assess all the materials in that blasting and tell you that this material will not go through your crusher because the size of it is bigger than 450 millimeter, which you have set at the boundary. So here, let's see the size of this material. The size of this material is 0.507 6 meter, which is 507.6 millimeter. And definitely that material will not go through our crusher of gap 500 millimeter. And you can see how to use that to assess your blasting. And what can you use this to do? When you want to give direction to your loading, you tell your loader where that material is located so that you don't keep doing the sorting and, find space of where that material is, and you don't want to do guesswork. So you can get that. Then another thing is that you can do that with the heat map. You can actually turn on the heat map. Those material that are showing red are material that are oversized, very large material. The material with blue are those fine material with, small sizes. Then the yellow, the hotter the color, the bigger the fragments. Then you are done with that. Doing more introduction about how to use the editing tools. So other editing tools that we have here is called the box delete. So it's just like when you click this, when you check this on, it allow you to draw like a rectangle or a square. Anywhere you draw that rectangle is that you want to clear those sides and you want to identify them by yourself. Then you have the circle delete tool. Here you can circle round a portion and it will delete that place for you. Then you can do editing, or where you are having, excessive, you can use it to adjust that. You can use it to just fine tune your analysis. Then you have the circle, delete, and outline. In this case, anywhere you circle around, any outline around that area will be deleted and a new one will be created around it. So that's how you use that. And you can use the Ctrl Z to return back to your previous editing status. Then we have the disintegrate. The disintegrate to work very fine, especially when you have material that are actually of fine and you can delineate them yourself. So I want to apply the disintegrating tool. So before you apply the disintegrating tool, you first use the lasso, delete, and outline to mark out those areas you want to actually disintegrate. In this case, I want to disintegrate here. So you can apply the disintegrating tool here. So you see, it will disintegrate the material there down to a very low class, what it actually represents in real life. So then another thing here that you can use in such scenario when you are having like an over crushed material, like fine like dust. So like a scenario we have here, you can see here is like a crush, like a ground crush here. So you want to apply the lasso, delete, and outline first. Then these are two called mark as fine. You apply it to that area, then it will be painted white. It's marked as fine. Every of the material there will be assigned a value based on the scale factor, which will be just 1 pixel as a function of your scale factor. Then another tool that is here is ignore. In scenario when you capture an image and you include maybe an excavator bucket, or somebody is standing beside the mock pile and you don't want to include them in your analysis, or you have an helmet or the likes. So you want to first identify, select the free draw. Let's say we have an helmet here. You mark the helmet first. So the helmet is within this region. So then you apply the ignore button. So everything in this region will not be included in the analysis. The software will identify them as material that is not part of the rock that you are analyzing, okay? So I want to turn that off. I want to go back to my previous editing format. You click Ctrl Z or that. Then we have the area of interest. So in scenario where you capture an image that, goes wider out of the pit, so what you do is to use the area of interest. When you turn it on, when you click the plus button, it gives you more points. So you can adjust those points and cover those areas that you are interested in. You can see. So this is the area that will be included. Maybe you have excavator or plants in this side, so you want to cut it off. It's just like cropping. So you can crop the image and the analysis will be limited to this region within that line. So I just want to return this back here, then this here, and this here. And so you can generate as many points as possible. So that is that about editing. Then another thing you can do with our WipFrag is that WipFrag can do color detection for you. I've shown you how to identify spec border here. So it can also do color detection for you. So you can set two colors. For example, those people that are familiar with, industrial mineral like dolomite, you have like off-white, off-white, pure white. And in scenario where you have two materials that have distinct different colors, so the software can tell you the percentage of each of those materials that have a particular color set. So here you click select, then you click those material that you are interested in. This case, in this material, we have just two color. You see the white color, it could be those material that are of high grade. Then we have intrusion. You can have intrusion, like you can see this black spot. The software did not include those black spots in this color class. So you can see these are the white. You click the white portion of the material. Then we have other color as black or like gray. So sometimes it could just be like granite intrusion, like a dilution in the material. So you want to know the percentage of the material that is having dilution. So you set the second color, which is the black one in this scenario. So I'm selecting the black portion of the materials as the second color. So this has been selected. So we have the black color and we have the white color. So you set that. Then the last step is generating the particle size distribution curve. Now, this is the deep learning asking you, how is my performance? Oh, you can just say, oh, very good. Then that is just that. Then you continue. This is the particle size distribution curve in this case. So now I'll be going back to my slide to explain. Okay, let me just explain that by myself and leave my slide as ahead to save time. So this is the result, the particle size distribution curve. So one of the things that we're saying here is that you can edit the name of the blast here. Maybe you want to change this to pit 1 blast A. Oh, sorry, don't mind me. So pit 1 blast A. So you can edit that. You can edit that. Then if you want to edit the real name of the file, you can do that here. Just click it, blast A here. Then if you click this, okay, here, I forget to mention this. If you click here, you can have information about the blast, the model of the camera that snap it, the editing time, the time you take to edit. Then this is where the GPS information comes in. If you have information, image that have GPS information, the software will identify it and include it here. Then you can use the GIS to spot it right on the mine site. Okay, so going back to our analysis. So this is, you have edited the name. This is the date when the analysis is initiated, the software version, the name of the software user, then the window version is what we are using, and that's what we have here. If you are using Android, you see Android, the iPhone, you see iPhone or iOS. So another thing is that you have a size class summary. So in this size class summary, you can only include, so this is just like the results gets the sieve analysis results, as the case may be, in the lab results. So this is the percentage passing size of the material, and this is the size of the sieve. So this is the summary of the size class. You can have it just in 6 parameters at once. So the first parameter you have here is XMA. So this is maximum material, the maximum fragment in the blast we just analyzed. This is the D50, which is the main size. The D50 is just showing the size, the average size of the material in that blast. So if you have, for example, a crusher of 196.99 millimeter, only 50% of that material that you have blasted will pass through. Then you have the D99. The D99 is showing the particle size that will support 99% of the material in that blast passing through your sieve or the like. The same thing is applicable to the D80, to the to the D90. So here you can, when you right click this, you can adjust those ones. You can remove from here. You can only add 6 parameters to that parameter bus at once. So if you have a particular size class that your company is interested in, for example, those people that are into construction, the riprap people, they are interested in D85, the D15, and the D50, which are those size class they use in selecting the stone that will definitely fit into riprap construction. So you can just add those size class that you are interested in. Here, I want to add the uniformity index. Then here, I want to add the color ID. I want to remove this and add the second color ID. So you have other parameters. So here, remember, we set to two color ID. The white, the material you have blasted, 88% of them have pure white color, while 7% of them have black gray color stain. Then if you add these two colors together, these two percentage together, okay, Ayodele, I see you raise your hand. You have a question?
Not really a question, but then I would love it if you could a bit be specific about where to click because I can't say for all that, but for me here, it's probably a bit difficult at times to get where exactly to click to add or to get something. So probably like okay, we have to when you're clicking on editing the size of the listing, like just probably mention of okay, I'm clicking this particular place because most
Okay.
times we could not see your code.
Oh, okay. Yeah, sure. All right, thank you.
Thank you very much.
Yeah. So here, if you want to change those fragments, particle summary, sorry, if you want to change the particle parameters that you will see in this place of the curve, all you need to do is to put your cursor on this and right click. So when you right click, it gives you option to remove. It says remove an item to select another. So when you remove this, remove, so you can add another sphericity. So you can add that. So the D50, as I've explained, the D50 is the mean size, the 80% passing size, 95% passing size, the color ID for color 1, color 2, color ID for color 1. So, and in this case, we have the white color, we have the gray stain. So for the white color material, 88% of the material in that blast is having white colors. Then 70% of them is having a stain color of gray. So then the sphericity is just showing the average of length to breadth of the material that you have blasted. Now I want to add the uniformity index, because I will explain more information. The uniformity index is showing how uniform the blast is. So what are those properties that shows you how uniform your material is? I will show you in the slide. In my slide, I have a little note there. Then another thing that you can do is you can click on the bar chart to see more information about each size class. So, and you can also edit the sizes that is displayed here. All you need to do is to click here. Let me move this here. So you can see this is the summary, the size of the sieve. You can only have 25 sieve at once, max. So then you can see the percentage passing. So if that material we have analyzed is passed through this sieve set, the 100% of it will pass through 1,000 millimeter sieve match. Then 77.73% of the material will pass through 500 millimeter sieve match. So you can adjust this by just putting your cursor on it and right click. Then when you right click, you have it. You have this. You can click here. For example, I'm interested in adding 800 millimeter size class. You had it. When you click it, it will be added automatically to the analysis. You can see 800. So you can select the particle size that you want to add. So what are those particle size that is very important you should include in your particle size distribution curve? The first one is the crusher inlet, the gap of your crusher. For example, in this case, in this tutorial today, I will be assuming my crusher inlet to be 800 millimeter. Then I will be assuming my crusher outlet, okay, to be 75 millimeter, okay. So this is my crusher outlet, and the maximum material that can go through my crusher is 800. What my crusher is producing is 75. I will tell you the reason why these two size class is important in my final explanation. Then another size class you want to include is the size of the buckets that will be loading the material in the mine site. Let's assume I'm using 500 millimeter size buckets. Now I want to show you how to set specification for those important size class, beginning from our crusher. A good blasting is a kind of blasting that produce a size class that can pass through the crusher without secondary blasting. So we want to define our good blasting to be a blasting that at least 80% of the whole material should be able to go without secondary blasting. Then maximum 100% of it should be able to go through the crusher without secondary blasting. Remember, we have set the size for the opening. Now for the outlets, I'm assuming 75 is the set of the crusher. Now, the set of the crusher, I'm assuming for us as a company, we believe that if our engineers can help us produce more of 75% size class, that is, if all our material is 75% size class, which is not possible, we don't need primary crusher. We only need secondary crusher. We are skipping one stage of our crushing. So we believe that if possible, in all ways, that we can have at least 10% of our material being of this size and maximum of 100. If everything is in this size class, that means we don't need our primary crusher again. We just go ahead and buy secondary crusher. Then another thing is based on the bucket. We want to believe that during the loading operation, 80% of our material can be loaded by our excavator and probably 100. So this is how to set specification envelope. So what the software does is that it programs the particle size distribution curve and tell you when this specification is met for your production. So this is how the specification curve is created. You can see there's additional yellow curve on the particle size distribution curve. So, and that is based on our specification, the primary crusher inlet, the primary crusher outlets, the excavator bucket. If you have other specification, maybe the secondary crusher, you can include them. Maybe you have other specification size class, maybe for the separation techniques. Maybe you are using gravity separation and you are mining gold, and you have a particular size class that will help you to get more of your concentrate. You had that size class here too. So here we set three specifications. Firstly, the software is telling us all of your material will pass through your primary crusher. You don't need secondary blasting. Oh, good. We say kudos to our blasting team. Then 75%, 17.68% of the material too will also go through the primary crusher without any crusher impact. You are saving energy. You know, the more of material that is coming in contact with the plate of your primary crusher, the more energy you are using. So if at least 17% of the material can just go through the crusher, you save more energy. Now, you know, we are done with downstream. Is this blasting good? Yes, it's good. Do we have any issue with downstream operation? No. Do we need to do secondary blasting because of downstream operation? No, because all these material are the material size is lower than the crusher input, crusher jaw gap. Then coming to loading equipment selection. Now, our excavator, by definition in today's tutorial, is that our excavator is 500 millimeter bucket size. Now, what percentage of the material can the excavator load? The excavator of 500 millimeter bucket size can only load successfully. Not that it can't load it, but as fast as possible. You don't need to keep moving around it because it's bigger than the bucket. Only 77.73% of the material will be loadable directly. That is not bigger than the buckets. So then you want to have more information about that, and you want to know how many particles will definitely not be able to be picked by your excavator, then you go back to the particle, you go back to the edit assist tool. All you need to do is to click here twice, and set that particle size and just put it here, 500, then load it. Then it's based on here, based on this single picture, only this material would not be loadable for your excavator. Then others are cut off in the picture and the software can analyze them. Though then maybe if you have additional image, maybe this is the first section of your image, you have another section of image that capture this, then you get full information about if this boulder here are bigger than the excavator bucket. But for now, in this image, this boulder is not going to pass through, is bigger than the excavator bucket. And that is how to set the specification envelope based on downstream and based on loading operation. Then another thing I will be showing you here is the blast cast. The blast cast is just up here where my cursor is, and the name of it is called a toggle blast cast. So when you click the blast cast, is a simulation model. You can use that to simulate, to optimize your blasting. So here, the blue curve that you are seeing is the curve of the actual blasting that we have done. The red curve is the curve of the simulated, the optimized blasting. So for you to do the optimization, you have access to, you have access to optimize your controllable parameters. As we are all aware that the controllable parameters are just those boarding spacing and blast design parameters. So if you want to make adjustment to that and see how it's affecting your fragmentation, so all you need to do is to come here, then you right click this, then you can see the interface gives you parameters, the parameters that you can play around with and simulate your blasting to what you want. And this model is not our model. Is called the KCO model. It's a model developed by Offin Ottolini. So is an extension of the Kungstram model, but in this case is called the Swebeck model. So that is the model that the software is using. So here you can adjust the bench height. You can see the bench height is being adjusted, and you can see the effect of the bench height on the fragmentation curve. So you can reduce the bench height and you see how it's affecting. Then you can adjust the boarding, which is the distance between two holes in different rows. So you can see as you are adjusting, you can see how it's affecting your blast output. So you can adjust that and you can make adjustment to that, and you see how you are improving your blasting at the lower side of the curve and at the upper side of the curve. And you can change the parameter to empirical, that is in feet, and to metric, that is being meter. So the drilling accuracy is the accuracy of your drilling operation. Then the rock factor is, if you have it, you can calculate that. If you have information about the rock mass rating, the rock density index, and the rock hardness, then you can have that. But if you don't have that in your mind, you can toggle it auto, then it will be calculated for you. So that is that here today. Then if you want to extract the result, you can click here. You can see export. You can export as PDF, as image, as CSV file, then as ENA file. This ENA file is just a kind of file that only WipFrag can open. Then another thing is calibration. The calibration is applicable when you have more fines material, or when you want to calibrate your image in the lab. If you have your sieve analysis results, so you have your sieve analysis result based on weight, based on cumulative percentage passing. So all you just need to do is to put the sieve result here and the cumulative percentage passing, and the software will give you the best model for calibration, and that can be calibrated. Why do you need calibration? You need calibration in scenario where you have some fine materials that are being covered by those boulders that you can't see with your eyes. So the calibration help you to, back calculate those fines that you can't see with your naked eyes, and also help you to fine tune the curve and account for other parameters that are other materials that you can't see with your naked eyes. So without be what I will be showing you here today. Okay, second to the last thing I will be showing you today is how to merge two images together and give you a single result. So here, for example, today we are imagining that we have visited a mine, and we collected images from the mine, and we have collected 4 blast pictures from the mine from a single blasting. And we have analyzed that here, and we have created a folder for it, pit 2A1. And these are the pictures we have collected from that pit. We have analyzed those pictures and we have it turned on as green. All you need to do, create the folder here, as I've explained. Click here, you create the folder, drag the picture in there. This is picture 1 from a single picture 1, 2, 3, 4. 4 pictures from a single blast, because you can't capture the whole of the mock pile in a single blast. So all you need to do is to put that in, then close it. Then we have the 4 images here. Click the file. Then the file will give you the 4 images being meshed together. So then you can edit this to be final results. So this is the final result, which is for a single blast, whereby you take 4 images. If you take 5, 6, as many images as possible, you can merge them together and you get the final result. And as you can see, the X marks the maximum material in the 4 picture is this. The D50 of the 4 picture is this. The combination of everything as a single picture, as a single blast, the D50, the uniformity index, the color ID as applicable. Then when you want to see the picture, oh yeah, I forget to explain the bar chart here. So when you click any of the bar chart is just explaining data point for each size class. So this is the data point for 500 millimeter sieve. So, and the implication, what the information being given by the bar chart is the percentage passing size and the percentage retained based on this single size. So the percentage passing is telling us now if we have a sieve size of 500 and those materials are run through this single sieve, 87.23% of the material will pass through, while 12.7% will be retained. And the percentage weight that is representing that material is just 1 boulder that will not be passing through 500. You can just see here, if you have 125 millimeter sieve size, 77 particles will not pass through, only 38.26% will be passing through. Then when you want to see each of the image result, then you put your cursor on this, click right click, then click below the composite, then you see analysis, then you see 4. When you click the 4 analysis, you can see the 4 images, how your blast is being improved in the pictures. You can see them here, live and direct. Then you can compare them together. You can see the 60% passing. When you trace it down, you can get the particle size, and that is how to merge together. And there is another way to merge. There is another way to merge when you have this kind of scenario. Maybe, for example, this is just the 2 pictures that is representing a single blast in this pit. So you can just take your cursor up here, click select the 2 images you want to merge, go to the 3 dots up here and click merge to view chart. So you can click that, then the 2 pictures have been merged. So you can just name that blast 1 for this case. So this is for blast 1. This is the 2 pictures we have captured from blast 1 in pit 1. So you can see the 2 pictures together separately also. This is the 2 picture, and you can see them as combined as projects. So that is how to merge in the other way. Then if you want to send images to WipFrag team to analyze for you while you pay with your image credit, all you need to do is to capture the picture, set the scale. Then when you are done setting the scale, you click the select button, click the picture you want to send over to us for us to analyze for you using our WipFrag. Then you click the WipFrag. Here I can't use the WipFrag because I've already analyzed the picture. So let's see here with this picture here, I can analyze with the WipFrag here. So click select the picture and click the 3 dots, and you can send over with WipFrag. You submit this picture to us, and our technical experts will analyze that for you within 48 hours, and you get the results. So you can submit here, and your image credit will be deducted to analyze for you. Then you get the results, and you can open the result after 48 hours. You can also share your results. For example, in what I'll be sending to you to try on, you'll be sharing your results with me, And this is how to share the results when you are done with the tutorial assignment. Click you are done with the analysis, you click select. So this is, for example, if this is the tutorial analysis and you are done, it has marked green, you click here, then you go to the three dots and you share it with me. Click share. So for you to send it to me, you have to add my username, Giant Miner, of which I will send to you. So Giant Miner, then you add it. You had it. It's me. That's why it can't add me. So when you put my username, you add, then you save. So then you can share with me instantly. Now, showing you an interface of how UAV analysis looks like. Okay, this is a UAV analysis here. And this is how it looks like. This is the whole mock pile. You can see how our deep learning is the same analysis, it's the same procedure. Then you apply the deep learning here. You can do your editing. This is fine. This is fine material. Then we want to mark it as fine. Yeah. Mark as fine, mark as fine, mark as fine, mark as fine, mark as fine. So you do the editing. Then when you are done with the editing, you can spec it based on the border. When you are done with the editing, in this case, you can check it. This is the analysis. This is for UAV. So it's just the same procedure. When you are done, you don't need to set scale. One advantage of the UAV is that you don't need scaling objects. The scale is generated automatically by the software using the GeoTelf properties of the image that you are stitching together. Okay, so when you are done, you can generate your curve also. Generate your curve, and the curve is still the same thing, just still the same thing. So in this case, I've edited my own size class, so you can remove some size class. So in this case, I'm only interested in this size class as I've mentioned. My primary crusher inlet size, my primary crusher outlet size, my bucket size range. Imagine I want to select any of this bucket size, what percentage of the material will be passing through. This is UAV analysis. Okay, and that's how to check it. Now, how to check it on the GPS and how to interpret it on the GPS. When you click the GPS, then you come up here on the layer, map layer. Then this is the one we just analyzed, the do know. So this is where this blasting takes place. You can see more information about it. There is a vehicle during the analysis when taking the picture with the drone. This is location where the picture is taken from. You can see this one mine here, this is another mine here. This is community. So you get more information about that from the software, and you can see the blast. Then you can see the heat map. You can see an heat map activated at the area where the blast is happened. So the implication here is that you can see the size class distribution. This is the D80. The 80% the 80% size, the size that will support 80% of the material passing through. So when you turn that on, all you need to do is to just click here, or you just left click the mouse and you have access to this if it's based on color ID uniformity. So let's begin with based on D80, which is the 80% percentage passing. So you turn on the D80. So this grid is 10 meter by 10 meter. So you know where your pit is. You have a reference point here. So when you measure 10 meter here, 10 meter here, 10 meter here, 10 meter here in your pit. So this is the material in this particular phase. Or if you want to reduce it to 20 meter by 20 meter, 20 meter hub grid. So this is 20 meter by 20 meter grid. So let's leave it at, this is 40 meter by 40 meter grid, just two sections. Okay, in this case, it's showing us red here, then blue here. Red here is showing that, is telling us that the D80 size class here is very high. That is, we have more fragments of large boulder, large size class here. Then in the blue part, it's showing us that we have more of material of low size for the D80 here. So if you want to see it more clearly, you can turn it on to 10. So you can see specifically how to apply this during your visitation or assessment to improve your next blasting operation. Is that when you visit the site and you are able to identify these points where you have the red dots, something might have happened during the blasting operation. The first assumption could be maybe the strength of the rock material in this section is too high and your powder factor is is not able to crush the material down to the specific requirement that you need. Maybe you want to increase the powder factor. Another scenario could be that the burden here is very large. So before the detonation process, the explosive wave is not able to complete the traveling phase before the explosion stage. So maybe you want to reduce the burden here in this particular side, and where you're having fine material over crushed, maybe you want to less the burden in that part so that you don't keep wasting explosive energy and producing over crushed material. If it is that case, then another thing could be that there could be a fracture, a discontinuity on the wall that support the escape of the explosive energy, and the explosive is now producing more of boulder in this portion. You want to give consideration to that part. It could also be that you have misfire, blowout, cuts in your detonation cord, or maybe the explosive is deflagrating at this point. So you want to investigate. So the software gives you information on how to do that. Another thing that you can apply that here is that during the loading operation, you can easily tell your operator, oh, I want you to start loading from the west eastern region, northwest region, and at the east flank, you have more of boulder. We want to load that later so that we can start our drilling operation from the flank where you can easily load and you can spend less time in selecting the right material. So the map can be used for a lot of application. So this is based on, you can also check it based on the uniformity index. How uniform is the material? Those places that you have red dots, the materials are not uniform there. So then finally today, what I'll be showing you is how to interpret the uniformity index and the uniformity index value and the DAT. So here on my slide, I will be showing you on my slide right now the final note. Okay, yeah. So I've explained this. If you need a slide, I will send it to you. I've explained what this stand for, what the DAT stand for, cumulative, the envelope, how to send it, then the histogram. So I've moved fast ahead of this. I've explained the blast cast. So the uniformity index, when you have a uniformity index of n value equals to 3 from the result, this is how the material looks like, and this is the interpretation. It means that one of three, it means that this is characterized by a very uniform size distribution where the smallest common visible block is about 1/4 the size of the largest common block. So this is just like as an interpretation, you can see what n equals to 3 looks like, n equals to 2 looks like. This is when you have, the ratio between the fine material and the biggest material to be 1/5. 1/5, then the ratio is 20:1. You have at least 20% of it is coarse, then 1% of it is fine. This is n equals to 2, n equals to 1.5, n equals to 1.25, n equals to 1, n equals to 0.5, where you have over crushed material. So when you are analyzing the blasting and you have n equals to 5, that means you are using high powder factor and it doesn't have work to do, then you have to crush the material down for you. So and in such case, you have 1:15 ratio. So how to interpret the DAT? So the DAT is applicable in the bond index equation, where you can easily calculate the work input by your crusher during the crushing operation. So the software will supply you with the PAT and the FAT in case of the output of the crusher. So when you have the PAT and the FAT, and direct interpretation is that when you have the crusher open to be X and the crusher outlet to be Z, so you want your DAT should be lesser than X. That is, the crusher inlet size is greater than the DAT size. So automatically you can, predict what your work index is, the cost of crushing the material, and how to enhance your downstream operation. And this is just explaining more further to you. X is assuming now, this is just explaining what I told you about the specification envelope setting. When we assume our crusher inlet to be 1,200, we add it to the size class, we set the specification, and the crusher outlets to be 100, we add it to the specification. So we see the number of energy, the rate at which we are saving energy during the crushing operation. So, and majorly, during your crushing operation, there are blasting operation. There are 3 ways that your blasting operation can help you to save energy. at the downstream stage. The first way is that when you are producing a kind of DAT that is lesser, your DAT is lesser than your crusher inlet, then you have less energy. You need less energy to crush the material because the feed will just go through the crusher and it have less work to be done. Then the second way is to decrease the work index. And how you can decrease the work index is having more micro fracture in the material such that little impact the material is already crushed. And you can do that by adjusting your design. So, and that is why you need something to control as a reference point to know what to do. And that's why the software is supplying you with quality information to do that and know when you have more material that is of good uniformity. So then the third way to improve your crushing experience is by having more of bypass material, which is the Z, as I've explained in the specification envelope. And you can easily do that with the help of the software. All right, I've explained this also, and this is the red point. This is just showing you the UAV. So the software is available in different languages. I've explained that. So you can get the software as annual, as by pay, and as I've explained that. These are just common error and how the software handles it. And I've explained some of that. And this is information about me. You want to contact me, you have any question, inquiries, send them to my mail. Get more information about the sampling guide. You can download that here. Then you can visit our website right now and learn more. We have tutorials and every other information that you need there. Thank you very much for your time. So let me check through your questions and answer some of it. The moderator, can you just help me go through the questions? Hi. Hello.
Hello. Yeah, I'm here with you now. I was trying to see on my microphone.
Okay.
Yeah. So the question we have here is the person said that you can see the picture matched half green colors, indicating that they have been analyzed. Then can we
Yes.
match those with red colors, not complete too? Like, can we match the images that we have not analyzed? Can we match them together too?
You can add them, but you can only add them only when you have one step to be completed. So I would like to demonstrate that so that you see. Okay, let me turn my screen on to WipFrag. Then we go back to the merging. So for this case now, you can only add, you can see this, you can see the red dot. So this is showing that I still have 2 stages to complete. So you can only add those ones that are only having 1 stage to complete, like this. Like this image right now, I've set my scale, I've done my edge detection. Then the last stage that is left for me is to generate my particle size distribution curve. So when you are, if you, for example, let's do it as an experiment. If I click this, then I click the one I've completed, then I can mesh them together. You can measure it, you can see successfully because you have already set the scale. If you don't set the scale, the software cannot analyze it for you. Definitely, you've not set the edge detection and you've not set the scale. You won't be able to merge it. But when you mark it as green, or you have only 1 step left, that is the PSD stage, generating the particle size distribution curve, then you can merge it together. The software will just generate the particle size distribution curve straight away. Yeah. Okay.
Yeah, I think that answers the question. And I believe for now that's the only question that is being sent to the chat report. But then if any one of us has question, please we can turn on our microphone so that we can just ask. We'll be giving a minute so that we can have the responses from you. So if any one of you have questions to ask, please, this is the time for you to ask your question. Now you can just switch on your microphone, then you ask. We'll be having a very limited time for us to know those that want to ask questions. So can you let us do that, and from there we'll know if we have questions or not. Please, can you all hear me at all?
Yeah, we can hear you.
Yes, we can hear you.
Okay, okay, that's good. Okay, so Yeah, no one is using their hand for questions. So I
Yeah,
believe we've all someone want to speak, right?
I don't think so. Yeah, I don't think anyone wants. If you have any question, if you don't have it now, you can always send it to me, to my mail. You have my mail. Just send it over. Then send it to me.
Yes, sir.
Then it will be attend to. Yeah.
Okay,
Yeah,
sir.
I
But you will
believe
mention
that
on
that is
sharing
what
your
we.
credit
Yeah.
when the other time, sir.
Yes. Okay. What is the question?
So,
Yes, I will only share credits, not to all of you. I will share
okay.
credits. Yeah. The only time I will be sharing credits is with those people. How many people are online now?
I think we
Oh,
have 15 attendees.
15. Okay, 15. Okay, you only have 15 attendees from your side, right? Yeah,
Yes, right now.
15. 15. Yeah, just note their name. Then they will get a image credits. I believe all of them have downloaded the software. And I will just, okay, this is what we do. Everybody, all of you can download the software now. Then I want you to divide the 15 people to 3 groups. So then each group will
Okay.
get image credits. They each group will get image credits to do the tutorial assignment I will send to you. Okay. But I want first everybody to download the software, register with the software, then learn on the demo. So when you try the demo images, you don't need image credit to try that, to learn on that. Then when you are done with that, then the three groups will select one person's account. Then I will send image credit for the 3 groups. Then you analyze. Then I will check. You share with me as I've explained to you. So I will send the image credit to your president or to the person that we are in contact with through mail. Then he will share with you. Then you can share with me directly on my WipFrag. Then I will access it on my WipFrag. I think I show you how to share, and this is my username. If you want to share with me, it's Giants Minor, Giants Capital, Minor Capital. So each group sent to me, but still yet I want everybody to create account because I can decide to send you guys each image credit from footer image credit because I have their image credit. They have like 200 image credits, so I can decide to share that with these 15. With the 15, we only have 14 now. Yeah.
Yeah, I believe that should be in you. Yeah, we have 14
Okay,
years.
yeah, you guys is 14. So I can share with the 14, no problem. Footer has image credit. So I can share 14 out of it with you guys. But I want you first to try. Try it. When you try it, do the demo images. Then each person should send the demo image that you have analyzed to me. Share it with me on the WipFrag. You don't need to send to my mail. Just you see, I will do that again. How to share. Click the image you want to share with me today. Then go to 3 dots. Then you see the link. It said share. Just click share. Then add the person you want. Maybe you want to share to Kenneth. For example, I'm using that as case study. I don't think that's his name. If you add Kenneth, you said,
That is it.
yeah, I had Kenneth. If I click save now, the image will be shared with Kenneth. Kenneth can access it and see the analysis that I've done. Okay. So that's how to share. So I want everybody to
All
share.
right.
Yes, I want you. Then this is the image. I want you to try the demo image. I want you to do is the okay. I want you to do that with dual scale, which is blasted rock C. The demo image you will be practicing with blasted rock C, and this is it. This is it. So all you need to do. I don't want to be doing the assignment for you. I want to be a nice lecturer like Dr. Idris. He will always explain everything to you and do it for you. He will do it for you, right? So you set the scale. You see, it doesn't take time, so it's not taking much of your time. I just want to show you
I'm
now.
not sure if you are seeing your screen right now.
Oh, then I want to, sorry for that. You see my screen right now, right?
Yes, yes, you can see now.
Okay, yeah, I just want to start again. Then, so sorry for that. I want to start again. I will use another image. because I don't want to do your assignment for you like Dr. Idris will do for us. So I'm using this as an example. So the image you'll be using is the blast rock C. So set the scale. In this case, it's a single scale, and it is 55, and it is 65 65 mm. So 65 mm. Set the scale. Put here 65, and it's mm, not millimeter, not meter, mm. So then we are done with the scale. Go here, generate the particle size curve. Assess the particle size as I've mentioned and ensure it is okay. Then generate your curve. When you are done generating your curve, I want everyone to set the specification envelope as I've explained. Set it, and when you are done, you share it with me. You just share it with me as I've explained. Type my name, then share with me. Then when you are done with that, then you get the image credit when I assess your analysis.
All right, thank you very much. Thank you very much, Engineer Giant Man. I really appreciate it.
Yeah.
And because our presidents are not here, so we have the software training organized, and we have the SME president here, and we have the App in Mind country director here. So we just give them 1 or 2 minutes to just briefly give us the overview of those that hosted this program for us. So, Mr. Oniwari, if you are there, please unmute your mic to give us just a brief introduction about SME, probably just a minute. Then the Sanusi, the country director of AfriMind, will do the same before we have our vote of thanks. Thank you.
Hello, everyone. Can you hear me?
Mr. Oniwari,
Can you hear me?
yes, we can hear you. We can hear you.
Thank you very much, Mr. Time Blessing. Very informative and
So is the speaker done so that I'll cut my recording?
Done? Yeah, sure.
Yes, you can do the recording. You can do the recording.
A very brief information about strategy for mining and metallurgical exploration. Strategy for mining and metallurgical exploration. Can you?
Mr. Okapo, we are not done with the we are not done with the training yet. Please mute yourself. Please mute yourself, Mr. Christian. Thank you.
Okay, I think we have you one house now.
Yes, we have one house now. Thank you.
Okay. So the Society for Mining and Metallurgical Exploration is a society that is actually having its headquarters in the United States of America, Washington DC precisely. So we have FUTA branch, which is the branch that is actually making a collaboration with Afriman Africa, Afriman in Nigeria for this webinar. So we have the FUTA branch in FUTA Air, which is one of the two branches or chapters of SME that we have in Africa. The second one in Ghana, is in Ghana. So the society involves a lot of activities which encompasses both mining and metallurgical engineering students. So that is just a brief information about. We have a lot of activities that we go through. We have the webinar, we have our cost visitation, we have our site visitation, and sometimes we go for fun too, because all work without play big chunks in boy. And that is all for now for the society.
Yeah, thank you, Mr. Odiwari. Thank you very much. Then if Mr. Sanusi Mwit is here, please you can unmute yourself and give us just a brief description about Happy Mind. A minute. Thank you very much.
Good evening, everyone. Can you hear me?
You can hear
Hello,
you.
can
Go
you hear
on.
me?
Thank you very much.
Yes. My name is Samson Louis. I'm the country director of SMEFUTA Nigeria. So AfriMine is a non-profit initiative dedicated to showcasing the beauty of the mining and mineral-related industry here in Africa, just from the name AfriMine, African mining. So AfriMine is also dedicated to mentoring the next generation of mining and mineral-related professionals. Now, AfriMine has three visions or mission. We have tribe building, we have mind shifting, and then bridge building. The tribe building means we build a global community of young professionals and passionate mineral students, which means we have students from Nigeria and other African countries. So it's like a tribe. We have students from different professionals from different countries here in Africa. Also, there is the mind shifting, which means leveraging of possible digital and emerging technology to change the negative narrative about mining. So there are a lot of negative narrative about mining. So we have the vision to change that narrative. And then there's the bridge building, which is to bridge the gap between the professionals and the students. There is also the countries that AfriMine are operating. We have 9 countries. There is Ghana, Guinea-Bissau, we have Nigeria, we have Egypt, there is Ivory Coast, DR Congo, South Africa, and then there is Burkina Faso. So I think that's just all about AfriMine. Now you can check us on afrimine.co/volunteer if you want to volunteer as an AfriMine volunteer. So afrimine.co/volunteer. Thank you very much, Kenneth. Over to you.
Yeah, thank you very much, my country director. It's very nice having you around. And thank you everyone for joining this meeting. I really appreciate. And we have this meeting. We have this opportunity thanks to SMEFUTA and the AfriMine. And these societies are just there for us to join. And please let us make sure that those of us that are here that we are not a registered member as part of the staff chapter. So please let us reach out to the executives. Any of them, our models are available. You can always reach out to me to get your form to become a registered member. From there, you can take on necessary steps, and do your task. You get certified, peradventure you pass, and the like. So we have the AfriMine there as well. You can become a volunteer from there, and the like. So a lot of these societies are there to just guide us in this field and make us professionals. Then I'll be giving Mr. Shukuji to give us a bit of time to help us appreciate those that are here present here and our tutor. Mr. Shukuji, thanks. Over to you.
Okay, good evening, everyone. My name is Chukri Joshua, and I want to specially thank Mr. Blessing Taiwo for the opportunity he gave us for taking this software training program. We thank you for your expertise and your patience and your enthusiasm to give back to the FUTA community. A lot of us here were already thinking of how we are going to go through the software training and like, but at least we see someone that understands where we are coming from. And we also appreciate you for your efforts that you put into delivering the training. It was a perfect training indeed, and we are extending this appreciation on behalf of the FUTA community, AfriMine and SME and all others that are in attendance for the training. Thank you very much, Mr. Taiwo. Blessing. Over to you, Kenneth.
You're welcome. Yeah, you're welcome.
Yeah, thank you very much. Thank you very much. So we will get across to Mr. Taiwo Blessing on the necessary things to do, and we'll communicate back to the students that are present here on what to do on our task. Provided if anyone have questions to ask us regarding the task, if anyone has questions to ask us regarding the tutor. And as they already dropped his details, his email and his number. So we can always reach out to him. He's a free person. He's always there to give back to us, and he's very, very, very ready to teach and impact. So I believe we are done with the meeting. We are done with the training session. We can say goodbye. We can say good night. And once again, thank you everyone for coming to this meeting. I really appreciate it. Thank you very much.
Yeah, all right. Thank you, everyone. Do have a wonderful day. Bye. Yeah, bye.